안녕하세요. My name is Eiji. I'm from Google Japan, working on Chrome and the web. In the previous session, I talked about a new web structure called ProGressWebApp. And in this session, I'd like to talk about the new additions to the ProGressWebApps, which is identity and payment. So let me start with knowing who the user is. So identity, I call as in sign-ins. You might be familiar with a screen like this. So this is where you log in to the website. As you can see, there's an email address and password field, so you can fill them in to get signed into the website. And you also see this kind of options, which is federated login. Maybe you may use other words like social login, like using the Facebook or Google account to sign into third-party website. And you might be most familiar with this part, forget password. Are there anybody who have never used this forget password? Nobody? If there is, I strongly not recommend doing that, because that means that you are using the same password all over the places. So it's not a good thing. So typing a password on smart devices is kind of cumbersome. So like you can make a lot of mistakes. It's virtual keyboard. It's really hard to type. Especially if when you are typing the password, it could be complex and doesn't make sense. So, and sometimes it involves some symbols if you're very security savvy. And to type symbols, you might have to tap like twice or three times. And that will lead you guys to use kind of simple passwords like this. So do you know what is this? The most popular password in 2015. This means that a lot of people use 123456 for their password. And the second most popular password was password. Can you guess what is the third? It's 12345. Very simple. So you might know why this is not good. Because the hackers can use kind of dictionary attack to try out this kind of very common used password to try to get into your account. So this is not a good idea to use this common password. That's why Chrome and browsers come up with a feature called autofill. So the browser automatically detects the form for sign-in and save the password that the users have entered, and autofill next time they have come back. So users won't need to remember ID and password by themselves. And in Chrome, the good thing of using Chrome is that if you are storing the password, you can synchronize ID and password across multiple devices, as long as you're signed into Chrome using Google account. And this also gives Android native apps a chance to use ID and password for sign-in. If you are not aware of that feature, you should check out Smart Lock for Password. 8 billion. This is the number of the assists that Chrome have made in a month for helping users sign in. So to a large extent, this should work without any effort on developer side. Chrome will wisely detect what is ID and password from the form and fill that in and help users sign in. But the best thing is that these kind of auto-detection sometimes fails, and you might experience in the past that some ID and password form didn't work to remember. So if you look at this form, you can see that there's display name, phone, and email. Can you guess which one is being used as ID or username to sign in? It's difficult, even for the humans. So what you can do is to use an attribute called autocomplete, which gives the browser a hint which one is for what purpose, in semantic way. So by using this, the browser can easily see that autocomplete equals username is the ID to sign in. And you can also specify current password for the parameter in the autocomplete to specify this is a password for the user to sign in. And if you want user to sign up or change their password, you can also use something called new password. This has two effects. One is it helps to prevent password manager from overwriting the previously saved password. And secondly, when you mark up your forms with new password, the browser can also tell that you need to generate a password. And we have the opportunity to auto-generate one for you, something like this. So this looks complex. And this is not exactly the password that it's going to generate, but it's randomly generates something, right? So we are experimenting with this feature behind the flag and the Chrome, but we are hoping to enable this feature in the, as a stable in the future. So by properly marking up your forms, you can get autofill feature very easily and precisely. But you can do more. You can do better job on handling credentials. And here comes the credential management API. At the last session, I have shown this example screencast, but the AliExpress is a shopping website from China, and they have adopted two Progress web apps. And as you can see, this is actually a website. Even though they are launching app from the home screen, this is a website. And as you can see, as soon as the app is launched from the home screen, you can see the blue bar shown up at the bottom, which indicates that the browser is letting you sign in. So this is one thing that you can do using a credential management API. So credential management API is basically controlled credentials using JavaScript. It has only 3 APIs. It's very simple, but it also has 4 benefits of using it. Let me explain one by one. The first thing is it will show you an account chooser instead of form. So this account chooser is using the native UI and very easy to handle. Just by tapping one of the accounts that you are going to use to sign in, you can skip the form and let users sign in without looking at the form. So these accounts are, of course, already stored in the password manager, and you can list them using the native UI. And also, when the user is trying to sign in, and when it succeeds, you can store those credentials into the password manager. The downside of using the autofill feature is it detects when you submit ID and password to the server. The password manager, regardless of it's successful or not, it will try to save ID and password. But by using credential management API, you can selectively use successful sign-in to store the information. And federated login. As I mentioned earlier, you can use third-party identity, like Google or Facebook or Twitter or even GitHub, you can use those kind of third-party identity to get signed into your website. But sometimes you have a list of long choice for a federated sign-in, and you can easily forget which one you used to sign in. So Credential Management API can also store which third-party account you have used, the user has used to sign in. And lastly, as I mentioned in the AliExpress example, you can let user sign in without even seeing the form or account chooser. To use this, you have two conditions. One is that the user has only one account stored for the password manager. Otherwise, you want user to choose one of the account. And the second is that user grants permission to use this feature. And you might think that handling credentials might be risky. So Credential Management API has a deep consideration about the security and well-designed. First, the navigator.credentials, which is a namespace for a Credential Management API, is restricted to use under secure origins, which means that you can only use this feature when the URL is HTTPS. And secondly, passwords are not directly exposed to JavaScript. When you're using a Credential Management API, you will get an object called credentials object. Inside the credential object, you have password, but you cannot access it from JavaScript. But it's available only when it's delivered to the server. And you might think that what if you can send that credential object to the third-party website? So the fetch API, which is kind of a XHR for the next generation, using fetch API, you can actually send a request to the server, but it only allows the credential object to be delivered to the same origin. So you cannot send that to the third-party website. And it also prevents from the open redirect to the third-party website. So you can consider using a Credential Management API. It's quite safe. So we've been working with some partners on the Credential Management API. And we would love to hear more feedback from you guys, if you could try. And the feature is actually already available on Chrome 51, which is the current stable version. So I'm hoping that you will try out this feature and give us feedback. To learn more, you can just search for Credential Management API. There are integration guide and code lab, demo and sample code. So there are a lot of materials. Okay, then I move on to the next topic, which is Payment Request API, which is a part of web payment effort. So as the mobile computing is getting more traction and people are using mobile phone rather than desktop, the shopping experience is also gaining more traction. But what is surprising is that the most of shopping experience, especially the conversion, comes from web instead of mobile devices, mobile native apps. So making the web shopping experience matters. But unfortunately, the conversion rate for desktop and comparing it to mobile, it's lower by 66%. So while users use 3,000 won on desktop, mobile people only use 1,000 won. So we need to fix that. And we consider that checkout form on mobile websites needs to be improved. So some checkout forms have improved since the beginning of web commerce. We have HTML5 and a lot of new kind of HTML elements to help improve the forms. But what hasn't changed is we have to manually input the same information again, and again, like credit card, a billing address, and shipping address. And as I have mentioned earlier in previous topic, you maybe use autofill for this purpose. So by using autofill, it will help credit card information and filling the address and so on. But it may sometimes fail to detect the precise position of the which one is addressed and so on. So you can, again, use autocomplete. By the way, with the autofill feature, you can get 25% increase in conversion rate for the mobile commerce. So it's very important for users to use this autofill. So by using autocomplete, you can help not only ID and password, but also credit card information. In this example, it's trying to fill out credit card number, and CVC, and expiry date. You may wonder, what else do we have? So just search for word, what WG autofill, and we have a standard for this specification. So if you look at this specification, you can have a list of parameters for autocomplete, so that if you have any forms on your website, just go and find which one applies to it, so that browsers will be even more precisely filling out those forms. So now the filling the form manually is automatic, and tedious task is much simpler. But it's fundamentally based on the same kind of existing checkout flow. We can do better. What if we can eliminate that form filling experience? Imagine a world without forms. So we want people to focus on just buy goods, not filling out the forms. And here I'm introducing the payment request API, the new addition to the W3C API to eliminate the checkout forms for users and for developers. A payment request API is a simple JavaScript API that helps the browser to collect payment information. So user can simply tapping onto the native UI to provide information about yourself, about the user, and send that over to the website. So with payment request API, you can streamline the experience. So now it's fast, and it's been required to tap multiple times. It's now single tap. Let me show you how it works. At first, the site tries to check out. Then you create payment request object, which will take the payment method that you can take. Then items detail what the user is going to purchase. Then it will be able to show, the browser will be able to show the native UI to help users make purchase, which looks like this. So by calling show API, the browser shows this payment request API native UI. and the user can examine the content of the payment, detail of the payment. The user can choose what's possible payment method, comparing what's possible from the website side and from the user side, and see what's merging, what's closing. And the payment method here only shows a credit card, but you can also add apps to this selection. So if you are providing payment processor service, you can make addition to this, like Android Pay. And finally, the user satisfied with the content of the payment checking out, the user can press pay to make payment. Then the payment processor, which is a third-party web application or server side, can process the payment and returns the response. And finally, using the payment result, you can send that, verify that information on the server side, and the payment process will be done. So, in addition to supporting credit cards, as I mentioned, payment request also has the ability to interface with other payment applications, like Android Pay. Google launched Android Pay last year, and we've seen phenomenal growth in our users, both in stores and in Android applications. However, we can truly call Android Pay, we cannot truly call Android Pay universal payment platform without supporting web platform. So Android Pay will be able to tokenize the credit card information and returns it to the web application, so it's safer to use it. And it also authenticates user using the physical device authentication methods like a fingerprint. So it's much safer to use it. So we are working on this API, and it's currently in Chrome 53. So as I said, Chrome stable version is now 51. And if you calculate that Chrome is releasing new version every six weeks, Chrome 53 is going to be stable in September. And also, Android Pay will be available to use along with Chrome for Android, the payment request API, later this year. But unfortunately, Android Pay itself is not available outside of the US, including Japan and Korea. But I cannot say about when it's going to be released, but hoping that it will be available soon. And in 2017, we will open up the API support for third parties. Payment, if you are providing payment processor application, you can join this ecosystem and make it even more open. And of course, this API is not working on Chrome, but it's working with other browser vendors. It's open standard. And you can expect other browser vendors to this effort. And we are working together with other browser vendors and other partners, and they are giving us feedback how to make the API better. So you can help us improve the API and the implementation with us. And if you're looking for information about payment request API, you can just search for it. But we are also working on the documentation for you to easily understand how it works. So please be patient at the moment, but I'm hoping that we can make the website much better and payment experience much better together. Okay, that's about it. So, 감사합니다. Thank you.